Hey everyone, this is Nick and I'd like to welcome you back to another video in our machine learning collection. Today, we're going to go over how to use Cloudera Machine Learning to validate some slightly more complex models. We won't be going over the basics in this video, so if you've never heard of Cloudera Machine Learning, go take a look at the previous videos in the machine learning collection. Today, we'll be using a publicly available NASA dataset that simulates how jet engines degrade over time. We'll show how using machine learning concepts in a cloud environment, we can go from simulation data to a cost-benefit analysis in just a few steps. We'll also show how we can run experiments to track specific metrics for many different scenarios that our predictive model could possibly be implemented in. Now, let's take a quick look at the data so we can better understand the challenge in front of us. NASA has provided a training and a test set for each of 4 scenarios. Each one of these sets consists of a batch of 1 to 300 engines, and each of these engines have a history of flights, or cycles, along with the engine data from that flight. The initial goal is to build a regression model that takes the engine data as an input and can estimate how many remaining useful flights an engine has at any given point in time. The data provided as test data includes the actual amount of remaining flights, allowing us to accurately test our model. With our regression model trained, we now take the following step of building a classifier on top of this estimated data. Since the ultimate goal is to alert an airline when an engine is likely to pass a certain threshold of remaining useful life, our classifier will be binary. Either the engine has enough life remaining, or it needs to be removed for maintenance. With some simple manipulation of the data, we add labels based on how much remaining life the engine should be removed at. In this case, our threshold is 40 flights, which is roughly 1% of the total life of the engine, as engines are typically designed to be overhauled every 4,000 flights or so. With the data labels in, we can now create a classification model. The final piece of creating our maintenance prediction model is to assign a cost value to each outcome. The 4 potential scenarios are as follows. The model correctly predicts that no maintenance is needed. This saves us no money. The model incorrectly predicts no maintenance is needed. This costs $1 million, as the engine potentially suffers extra damage from being overhauled late. The model incorrectly predicts that the engine needed maintenance. This costs $150,000 since the engine was pulled too early and still had some useful life remaining. Finally, the model correctly predicts that the engine needed maintenance. This saves us $500,000 as the airline can now prioritize maintenance crews and plan ahead to schedule the maintenance in an opportune time and place. Now let's go ahead and run this to see what our results look like for the first dataset. We go towards the end of the results, we can see the outputs of all the metrics we're tracking. It seems that our classifier had a 93% accuracy, and when applying our cost analysis, the total savings for this set of data was just under $5 million US. In order to declare victory, we now need to quantify how effective this overall system is by testing it on the rest of our test data. This is where we're going to leverage Cloudera Machine Learning's experiments capability. CML experiments allows you to add some metric reporting to your code, so that you can run many different scenarios or inputs and collect all the resulting metrics in one easy to digest location. In our case, we decided that the main metrics we wanted to show are classifier accuracy, area under the curve, and total savings or loss. We'll test 2 different thresholds for the amount of remaining flights we want to recommend maintenance at, 40 and 50, and thanks to the NASA data, we have 4 different conditions to test. This is a total of 8 combinations. Now let's go into the experiment section and begin to set up our runs. To set up a new experiment, we have to give it our Python script as well as some input arguments. In our case, we're inputting the file name, which determines which of the 4 datasets to use, and the threshold for flights remaining before maintenance is recommended, either 40 or 50. Here you can also determine how many resources each experiment should be allotted. This is very useful if you know that you can make heavy use of many cores, or if your program is mostly single-threaded, you can save costs by running it on less resources. We can also leave comments here for when we go back to look at the data. Once this process is done for each of our scenarios, we can come back to the experiments page and see all our metrics in one place. As you can see, our predictive model performed quite well along all our scenarios, but it did better under certain conditions than others. From here, you can narrow down where you may want to make improvements to the model, figure out what scenarios your model works best under, or fine-tune certain input parameters to see their effect on the model's performance. Thanks for watching today. If you found this interesting, don't forget to subscribe to see future videos. If you have any questions, head on over to the Cloudera Community. where there are plenty of other users ready to help answer any questions you may have.